Welcome to 12.2 sections with independent and dependent variables and events. This is going to be a lot shorter than 12.1. 12.1 with a lot of new material to cover. This is kind of just an extension of that. So independent versus dependent events. Well, if something is independent, you think, oh, they're good on their own, they don't need anybody else. Dependent, you might need someone or need something. Independent and dependent events are a little bit different. It's about effect. So independent events are events whose occurrences, or like when it happens, do not affect the probability of other events. And dependent events are events whose occurrences do. They do affect the probability of other events. So what do I mean by that? Well, we talked about drawing cards out of a deck with or without replacement. Maybe if I draw a card out of a deck and I draw a second one, if I kept that first one, that's changed the deck, changed how many cards there is, changed what cards there is, so that affects the next event. Independent events theorem. So we're going to say there are events A and B. So events A and B are independent if and only if, so it's a biconditional statement, if and only if the probability of both events happening So remember, when we have words like both, we multiply. We learned that from the last section. So the probability that both events happening is equal to the product of each probability. So what do I mean by that? Well, that just means that the probability that A and B both happen is the same as the probability of A happening times the probability of B happening. So that is the mathematical way to check if two events are independent. So here we have a group of 4 students, includes 1 boy and 3 girls, that's important. A teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Determine if randomly selecting a girl first and a girl second are independent events. Are they independent? Well, you're selecting someone, and then you're selecting someone else. That initial girl isn't put back into the group. She can't be the speaker and the recorder. So this is a dependent event. Because it is done without replacement. We aren't putting that girl back, so it does affect the number that you pull from next. All right, you roll a die twice in a row. What's the chances you roll a 1 and then roll an even number? So that is an independent event. When you roll a die, the first roll has no effect. So previous rolls do not affect future rolls. Just because I rolled a 1 first doesn't mean I'm more or less likely. So then there's something called conditional probability. So conditional probability we use, so the conditional probability of dependent events. Conditional, like if something is conditions, maybe you can go out with your friends on the condition that you've done all your chores. Conditional probability means something has to have happened. So the conditional probability of a dependent event is the product, so we multiply, of the probability of the first event and the probability of the second event given that the first event happened. The really important word here is given. So it affects the second part. So depending on if event 2 happens is affected by if event 1 happened. So the way we say the probability of B given A, so the probability that B happened given that A happened, we write like this. So that straight up and down line means given. So to get a conditional probability, it would be the probability of that first event times that second event given A. So here's some two examples where we would use this. So a bag contains 20 $1 bills and 5 $100 bills. You draw a bill from the bag and without replacement, so that's an important part of this, draw another bill from the bag. What's the probability that the first is a $100 bill and the second is also a $100 bill? So we have event A, which is your first is a $100 bill. And then we have event B, which is that your second is also a $100 bill. So the conditional probability, what is the probability that your first bill is 100 and the second bill is 100? Well, it would be the probability of A, that the first bill is 100, times the probability that the second one is 100 given that the first one was. So let's look at those probabilities. The first one is a $100 bill. Well, there are 20 $1 bills. There are 5 $100 bills. So that's 25 bills in total. So 5 out of 25 is a $100 bill. It's a 5 in 25 chance that you get 100 on the first pull. Then, how many bills are left? It's without replacement, so there's only 24 left. And how many of those are hundreds? Now there's only 4 left. So that gives us 20 over 600, or 1 over 30, which is about 0.033. So we did a little bit of that last section. This is trying to just giving it a name. So here, all right, at a school, 60% of students only buy lunch, 10% of students buy lunch and dessert. What is the probability that a student who buys lunch also buys dessert? So essentially, this is the probability that a student gets dessert given that they got lunch. Because what's the probability the student buys dessert who buys lunch has also bought dessert? So I know they bought lunch, so that's given. Well, think of 100% of students. %60 of them only buy lunch. 10% buy lunch and dessert. So what's the probability of dessert given lunch? Well, the fact that they got lunch is kind of a 70 out of 100 chance. The chance that they got dessert is a 10 out of 100 chance. So there's a 1 in 7 chance that if they got lunch, then they also got dessert. All right, and now please watch part 2. I know it's a little confusing. As we practice more and more, it'll make more sense.